Alright, time to do a speed run. Okay, so we're making a project for what is it? A USB to serial adapter, or not adapter, chip. This guy. Yes. So this thing, it's a UART to USB device. So let's get started. So I'm gonna just start it from the top, to be honest. I'm just gonna go through the whole design process. Actually, I lied. Not the whole design process. I'm not going to go through the component one because you guys just saw the video on it. Okay, so let's start with making a project. So I'm going to select the default layout, and I'm just going to call it, in this case, I'm just going to call it this guy. So uh, I am recording, right? Yeah, good. Um, USB to UART. Boom. Okay, give it a second. And for the schematic, I'm just gonna scroll down to the, where is it? Um, something. Yeah, the application note. And okay, I just made the project. Good. Okay, this one's not too hard. There aren't too many components, so hopefully it'll be quick to do the schematic. Okay, and then there's some capacitors. 0.1 UF. Oh, and by the way, if you guys have any questions, just shout them out, and I'll just answer them in real time. Okay, yeah, so I'm just gonna use some 0402s because they're small and they work for this voltage. So the and with these power capacitors, I like to have it where power capacitors are facing up and and I don't know, RF and signal capacitors are facing sideways. So we have VDD and regulator in, right? So, and again, I like to have the grounds and the power nets facing up because it just makes things a lot easier. So right now I'm just copying this layout. So VBus on both of them. Okay. Oh, and by the way, I don't think it shows right now, but in the recording, it will show what key presses I'm using. I'm using an OBS plugin, so that's why it's not showing it live. So, and then I'm going to move these to the side and I'm going to add in some more capacitors because, you know, these capacitors are pretty small, so you might as well add them. So I'm going to go with option 2, which just means you add in another capacitor. Oh, and I messed that up. So VDD is actually not connected to VBus. That actually makes sense because VBus is 5 volts and VDD is like 3 volts. So that's oops, wrong one. This one's connected to VBus, but VDD is not. So that goes to reg in. And then I need a 4.7 UF. Um, Probably this one. No. 4.7 U 0402. I'm just being a bit picky with my components right now because I want them to look the same. I don't want them to be using different footprints because then it'll look a bit dumb on the PCB. And I might as well put that one UF. In reality, I should get rid of the alternative, what is it, footprints and stuff, but there's a lot of them. It's just a lot of mess that's accumulated over the years, you know, so it's like, can't be bothered right now. Don't really have time right now. Yeah, nah. Let's keep them apart. Okay, so there's my regulator part. I need a 4.7 UF on VPP for in-system programming. Ah, that's for CP2109, but this is the CP2102. Yes. And you can actually show it on your schematic by clicking the eyeball. And then you can just drag the name around. So we don't need that option. And then they've got the suspend, the USB suspend stuff. Honestly, that's not really relevant. And I'll just put out VDD so I can put that resistor on the reset. VDD. And then reset, yes. So internally, right, these reset lines, they normally have a resistor built in, but you can always put an external resistor like in this schematic for noise immunity. The trade-off is it takes longer for it to reset when you apply the signal. Like maybe a couple microseconds. So it doesn't really matter unless you're like resetting it hundreds of times per second or thousands of times per second, I mean. But you probably won't, so you might as well put this in. And you can see on the schematic that the bar, that just means it's active low. So that means it resets when you pull the thing to 0 volts. Okay. Option 4, a resistor to hold suspend low on power on or reset. So yeah, you might as well put these options in. Like, if it's an option, then your breakout board should probably have it, because that just gives you more freedom to mess around with stuff, so that you don't need to do another PCB run, or you have to like put some bodge wires and shit, because that just makes things a lot more annoying to work with. The whole point of this breakout board is to be a lot accessible, very accessible, right? Okay. Yep, so the only two components we need now are the USB, ones. I'm just gonna move that sideways actually, because you know it's a signal thing, so you could. So if you're following my rule, then this is perfectly fine, because this is not like a power signal, a power resistor or whatever. And okay, and then you might as well move these designators around. I'm gonna minimize that. So it just makes things a bit neater, right? Rather than having overlapping symbols. You can change the justification with this thing in the corner. Okay. That looks okay. And then finally, let's just put the USB connector, USB-C, maybe? Yeah, this guy, right? yeah, this thing. USB-C connector. So with this sort of connector, or symbol, sorry, I'm just going to put it off to the side and use some net names to connect them because it's just huge and annoying to work with. So I'm going to connect the grounds. Okay. Connect the V-bus. So this is like your standard USB-C layout for, I would say 90% of your applications. Like, of course, there's stuff like power delivery, but we don't normally mess around with it. So, you know, if you're just doing a standard micro thing, this will probably be what you want. So, okay, so you have USB-D plus and USB-D minus. Okay, and then you just put them on the USB-C connector. Now with USB-C, there is one more thing to worry about, which is like this, I don't know what it is. It's something to do with the power, not power delivery, is it? I don't know. Either way, in this configuration, I think we're like configuring it to just be a low power thing, not those fancy USB-C devices that can transmit a lot of power. This is just your standard thing. So to be compliant, you got to put these resistors, these 5.1K resistors. In fact, if you like search it up, right? Uh, what is it? USB-C CC 5.1K. Yeah, so you can see this whole like thing about power negotiation and yeah, honestly, I just make it 5.1K to ground and then that works for me. You can read into the spec if you want. I'm just going to keep it short and simple because I'm trying to speed run through this. But yeah, for most micro applications, most stuff that you don't use power delivery, you just do that on USB-C. Obviously, if you have a USB A connector or micro B, they won't have these pins, so you don't need to worry about them, right? And then finally, the last thing is just to put some headers on this shit. So headers, and when you're making a breakout board or like a development board, you will probably end up like changing what headers you use to try and make it more compact later. But for now you just want to get shit on the board, right? You know, you just want to get stuff on the PCB design. So um yeah. So I think what I want is yeah, 4-pin header. I want a 4-pin header for the TXD and the RXD. Because 90% of what people are doing with this thing is like connecting it to their own stuff, like to their own serial ports that are just like dumb UARTs. But I will put more headers on because again, with the whole breakout board stuff, you kind of want it to be adaptable, right? So I'll put on the headers for the other, what's it called? Flow control stuff. Yeah. Oh, I almost forgot. You gotta put a ground pin up here. Put a ground up there. Yeah, that's it. Ah, and another thing you should check the data sheet for is these NC pins. Sometimes the data sheet says not to connect them to anything, but sometimes they say do connect them to ground. See, this one says not connected or tied to VDD. Um, not connected or tied to VDD. Okay, so in this board, in this chip, they don't want you to connect it to ground. But in other chips they might, because it's like thermal properties and stuff, but this one they don't. So we'll just follow their advice. Okay, so we got all these other lines. So I'm gonna get a 8-pin. Oh no, actually no. I'm gonna get two 4-pin headers. So what I'm thinking of right now is how it's gonna lay out on the on the what's it called? PCB. Of course, you can always just like put in a massive, like I said, you can just put in a massive header, and then, or you can always come back to it later when you're laying out your PCB, and you can think about it then. But I think I've got a good idea on how I want this to look. Okay, give me a second. What's V-bus connected to? Oh, V-bus goes to V-bus. Oh, I missed this one. Okay. So that's the whole point of a design review. You come back and you realize you're missing pins everywhere. So that's why you always have to do a design review later. So gonna put these guys on here. Oh, another ground. Yeah, so always gotta make sure your grounds are grounded. I'm just running through it. Okay, and then I'm just gonna give net names to everything. Here's a neat trick actually. If you, okay, this will show up in the recording, but if you have a net label and you press tab, that puts you into that pauses the whatever you're working on and focuses the property menu, right? If you have a pin like, let's say PA0, anything with a number on the end, and then you press enter to come back to the schematic, when you click it, it'll actually auto increment the number when you keep placing them. So that's a neat trick you might want to know. Okay, so I'm gonna just label these. So D, C, D. So the backslash gives the little over bar, which indicates that it's active low. What else would I put out? I guess I can break out suspend and everything. Yeah, okay. So I'm just gonna, okay, this is a bit of an annoying one. So to make things neat, I'm just gonna move this shit. And then I will just put suspend, sauce, and sauce. And then we'll just, again, I'm gonna probably move these what you call it, these pin assignments around to make it fit better on the PCB. But that's a problem for later. So DTR, DSR, and then RTS, and then CTS. Now, with this board, you can always just, you obviously don't need to do the physical connection stuff I'm showing you here. You can just do what I'm doing up here, which is just give it the net label and call it a day, right? But in this case, I'll show you both. So yeah, in this case, yeah, this net label is like, it's like a symbolic sort of link between those two pins instead of something physical, right? So it's up to you what you want to do. I would say use physical if it looks neat, because it's just a bit easier to understand. at a glance, right? Okay, so that's the board. I'm gonna annotate it. Boom. Execute the changes. So that gives everything a net label, a unique net label, so you can see all the numbers. Okay, save. And then we go to making the PCB. How are we doing for time? Okay, so I need to finish this in 15 minutes. Okay, if you have any questions, let me know. But um, yeah, I'm just gonna keep on cracking. Okay, yep. So everything's just put onto the board. There's actually how do I say it? There's actually an order to how these components are laid out. Like they didn't just randomly put them down, but honestly, in practice, it kind of looks like that. So I just start from wherever. So the first thing you do when you're making your PCB is you just lay out the components, to be honest. Like, you don't really care about putting tracks. You just gotta put it in a way that's like logical and they'll look neat. I'm just gonna hide the overlay because it's really distracting when you have tons of net labels. So I'm gonna press G and change the grid size. Um, Probably like 10 mil is always a good size to start with. So again, the whole goal of this exercise right now is I just wanna get the components in a reasonable position. So these are actually those two resistors I told you guys about, the CC resistors. I always like to just put them on the side of your USB connector. Just like that. Okay, this is actually pretty easy to lay out. There's not too much to worry about. So I'm going to put sus over here. What is this? Okay, so we'll have to be a bit reasonable with our layout. So because these two tracks need to go pretty close, so I'm just gonna flip them around like that. Ground and VDD. Okay, so I'm just thinking ahead of how this is gonna look. These two are obviously like high priority signals, the USB data plus and data minus. So you don't want to be like running them through components. Like even though this may look neater, that just results in you cutting off the USB lines and having to run them underneath, which is actually worse than like power decoupling. So that's my rationale for why I'm putting this like that. Okay, what else do we have? Another, okay, right, so, right. So when you lay out, components in the schematic, it doesn't really matter what sort of order you put them in. Like you can put the one UF here if you want, right? On the, oops. You can put the one UF here on the other side and it will mean the same thing, right? But in your PCB, it actually does matter a lot. And the rule of thumb is, that's the wrong PCB. The rule of thumb is you put your lower value capacitors closer to your chip, closer to your IC. That's because the effects of like the impedance are gonna affect the smaller capacitor more. So yeah, in this case, I'm putting the 4.7 UF behind the 0.1 UF, so the 0.1 UF is going to be closer, which is how it should be. Okay. and then the USB. So that's actually a pretty simple layout. Not much going on here. It's just a couple resistors and capacitors, and I think some of you guys will have similar layouts. Some of you guys won't. Like, um, Alice, I think you've got the I'm gonna say the worst layout. Like, it's gonna be hell for you. But some of you guys just have breakout boards, and that should be easy to mess around with. Okay, so again, I'm making sure my high value capacitors are further back from the chip, and I'll just nudge them a little bit inwards so that they're closer. Okay. Next step is to do your headers. So the headers, again, how I like to do it is you start with the small components like your capacitors, and then you work your way up to doing the huge components like the headers and shit, right? So for now, I'm just gonna put them approximate. Yep, so that makes sense. That one, maybe flipping it will be better. We'll see. Okay, so now I'm just gonna drag everything in. Okay, first before I do that, I gotta make sure everything's grid aligned, which it is. Only reason I want everything grid aligned is just because it looks neater. No real reason, to be honest. And then yeah, again, you do your small components first, and then do your large components later, and it just makes it a bit easier, right? Oh, okay. So actually, I actually wanna rotate it. So the reason why I'm doing this is again, the USB data lines are just like are the top priority signals. So you want to minimize the length of them, and this is as good as you'll get, right? Just straight lines. Okay, so that looks good. And then the next thing I want to do is make sure that it'll work as a breakout, right? So yeah, it's on a multiple of 100 mils, so that's good. Um, I guess what I'll do is I'll make this symmetric or more symmetric. Okay, maybe not. Oh, it's because the USB was a bit off the grid. Um, so yeah, making it on the grid just makes it look neater. That's about it. Okay. Actually, the way I'm doing this is okay. I'm just thinking. If I want this to be a proper breakout thing, so okay, now that I've got like an approximate layout, now I'm revising my original header selection, like I said, right? I want this to be a real breakout. So in that case, I gotta have parallel headers. I can't do this stuff where it's like 8 headers here and well, I could, but it look dumb, right? So I want 2 rows of 6 headers. That'll look fantastic. So let's go back here and change that to 6 headers. So 6, 2.54. Okay, maybe not. 6 pos. Actually not sure if we got 6 position headers. Um, one of these maybe? Nope, that's 2 by 3. And that's a 10 header. Okay, we might not have 6 position headers. Okay, so in this case, you can make the 6 position header, or you can be lazy like me and just put a 2 position header. So 2 pos. You can put a 2-position header and call it a 6. Yeah, okay, so I'll have to add some 6-position headers sometime. But for now, I'm just gonna get a 2-pos header from somewhere. Yeah, it's this one. Yeah, this one. Boom and boom. And remember, when we were doing the schematic, we didn't really care about how it would lay out. Okay, I'll see you later, Alex. Thanks for coming along. I didn't really care about how it would lay out, but now that it's physically here, we can do the layout proper. So I'm thinking the best way to lay out this would be to put the 6-pos header here, and then put RxD and TXD in the middle. So that's what I'm gonna do. So actually, it's gonna look pretty similar to the schematic, I guess. Yes. So to make this work, I'm just gonna move these around. Again, you probably should properly make a 6-position header, but since I'm lazy, I'm just gonna use two headers, just like that. Okay. Move them out a bit so that my designators look a bit more neat. Okay. Like that. And then shuffle these up. Great. And I think the last one is this side. So what I'm gonna do is, I think the best way to lay this out would be to put the ground header on the bottom, and then add some VBus. Right like that. Okay. Ah, whoops. I need to annotate this. So I press TAA to annotate. That's a hotkey you'll be using a lot, so you probably should get used to using the hotkey. I annotate this stuff, and then I update it. You can in this case, you can automatically link it, or you can decide not to. It's up to you, but the automatic link is mainly when you like change, like say you have a resistor that's like value X, you can do the automatic link, and if you change the resistor to like value Y, instead of like resetting the resistor to its default position like way off the board, it will actually just replace it in place. So you can see some of these headers got automatically linked and placed in place, even though they're like different designators. Sorry. Okay. Yeah. So again, like I'm saying, you probably should just use 2 headers instead of doing this. I mean, use 1 header that's like proper, but I'm lazy, so I'm going to do this. If you are doing this trick, you just gotta be doubly sure that you're placing everything on the grid, because you know if you mess up the headers, it's just not gonna work on the breakout board. And when you do this trick, you will get collision errors, and you'll have to make um, exceptions for them in the DRC, in the design rule checker. Okay, so I'm gonna move this one down. I'm moving these, even though it's like not the shortest distance to the pin, as you can see, I'm moving them down because it makes better better use of the board space because you can't really avoid having a big USB connector on it. So by moving these down, you're using up the additional space the USB connector creates, and it's a lot more compact. Okay, so now we've done the first stage of our PCB design, which is like doing the approximate layout. Second part is to actually start connecting stuff. So first thing I'll do is I'll just update the ground plane. So TGA. That's how you update the ground plane. And actually, the little tint you see is from the internal ground plane. So the default template gives you a ground plane on the inside. All you need to do is click on it and change the net to GND. And once you have that, and you repo by pressing TGA, you can see it connects to all the grounded elements on your board. Now it's up to you if you want to do ground plane on top. I'd say 99% it never hurts to have more ground. Unless you're doing like RF stuff. Even still, with RF stuff, most of the time you just want more ground. So make a ground plane because it definitely can't hurt. And then give it ground. And then again, press TGA to repour your ground plane. And then boom, you've got a ground plane on the top. And you can do the same on the bottom as well, but I won't do that right now. Okay, let's start making wires. So Control W. Yep. Gives you a wire. Now, a good wire size is 0.2 millimeters for most signals. You can do 0.2 millimeters, or you can do 10 mil, up to you. And for your grid, you mostly want to do like 10 mils around that area, or maybe 20 mils if you're doing like longer routes. Now this cursor, you can see it's got this circle. That's the hotspot snap. So you can disable or enable it by pressing Shift E. So you can see it cycles in the corner over here between hotspot snap all layers, or none. So with none, it won't snap to the centers. And when you press Shift E, it will snap to the centers, but only on the red layer, or your current layer. And then if you press it again, it'll snap to all layers, so even stuff on the below layers. But in this design, we've only got one layer. The only problem with hotspot snap is sometimes it just makes things off the grid. So if you want stuff to be on the grid, turn off hotspot snap. Okay, you can see we've got collision errors. You can just press TGA whenever you feel like to resolve those. Okay, boom. Again, let me know if you guys have any questions. I will do another wire over here, so like that. You can probably move it so that it doesn't do this bending, but in this case it's pretty much an aesthetic choice. Now with these USB-C connectors, they actually connect twice, so you can see they've got two pads for the same thing. And it's up to you how you do it, but I like to use this like layout. Okay, this via is way too big. Way too big. So press tab and then you edit your via diameter. I like to go with the minimum, which is actually now I think it's 0.5 millimeters, and the whole size you can do 0.3 millimeters. I should just change that in the default rule, but I'll do that another time. Now, when you're picking what layer to route your signals on, I reckon first priority is obviously the top layer. Second priority is the bottom layer. So the one on the very bottom. Then you can use the internal layer, the power layer, but the main point is you should really avoid using the ground plane. The ground plane is meant to be a solid, unbroken plane, because and that'll just make it so that you get better signal integrity and stuff. Again, the bottom layer, do try to avoid it, but that's like worst case. Yeah, I guess you can do some short routes over the bottom layer where your power plane is. Okay. Okay, this is looking all right. And then next piece is to do your V bus. Okay, so you can see right here there's a bit of a squeeze over here, so and if you really need you can change your grid size down to 5 millimeters, not millimeters, sorry, to 5 mils. And that will just help us route V bus out a bit more neater. So V bus is a power what's it called? A power net. Yeah, that's what it's called. The V bus net is for power, right? So you want to make sure that you keep the tracks as wide as you can reasonably expect. So in this case, it doesn't really matter, to be honest, because you're not drawing like amps of current, but keeping it large always helps. So you can put V bus like that, cut away the excess, and you can actually see the current from this more tab, and you can see it's about 1.9 amps at some temperature, but whatever it is, it's reasonable enough to not burn the PCB, so that's good enough. And then, okay. And then I connect the other V-bus. It's just good habit to keep all your power stuff connected. These are internally connected in the USB connector, so you don't necessarily have to bring these out, but it's always just good to have it all connected. So I'm going to move these to the power plane. And I guess I'll just bring it up here. Gonna hotspot snap it. That works. Again, if you click on a VR, you can see how much current, the maximum current, and yeah, 1 amps is plenty, to be honest. Whoops. Just didn't mean to do that. That goes somewhere. Yeah, sure. That'll be good enough. And I'm just gonna move this V bus so that it's not colliding with the ground. Okay, that's good. Now with these grounding capacitors, again, it's all about ground, right? Well, not grounding. Decoupling capacitors, it's all about ground. So you always want the ground, you always want there to be a short return path to ground. So put some vias next to each capacitor, just like that. And also put vias connecting it to the power plane. Although in this case, there's not really a power plane because this is like all internally, all of this VDD is generated internally. What I'm doing right now is I'm making another polygon exclusively for VDD. Polygons are just neat when you need to make thick traces because they actually flow around components, as you can see when you do the pour. And if you want to be neat, you can just trim that excess down. And then Let's do another polygon for the V bus. Yep, just like that. V bus. Now, here's one thing. When you pour the polygon, you can see the polygon or okay, there are two things. You can see the VDD just disappeared. And that's actually because what am I saying? This is because I think the area of the plane has dropped way too low, so it actually thinks you've just got like a random piece of polygon. So you can uncheck this option for like small pores, and then there you can see it comes back. Now for VBus, you can see it's not connected to this track. This is actually because of this rule which prevents the polygon from pouring over samenet objects. So you just want to pick pour all over all samenet objects, and then when you repour, it'll now be all connected. Yeah. The only things that I don't like about this layout right now is the fact that this ground is not connected to the top ground, but honestly it's not too bad because they've still got these vias, so it's good enough. And on further thought, I might actually just make these this V-bus connector just as wide as possible. So I'm just gonna make it. Actually, no, I won't do it with a thick trace. I'm just gonna use a polygon. So I'm just gonna set it to a huge grid size, so it's just easy to pour. Like that. And then V-bus, I'm just gonna bring it to the front. And yeah, that should be able to handle significantly more current. Just because it's way thicker, right? And in fact, I'm just gonna go all out and expand it even further. Right like that. Yep. And on the surface, I'm gonna also expand this out because I want the maximum amount of current being able to flow through this. So this tripling the amount of vias just gives it more current capacity. And then I'm just gonna put even more vias next to V bus over here. You might as well just spam them everywhere, you know? Just absolutely spam them everywhere. You can never hurts to have more connections to your power and ground. So yeah, that's looking good. Okay, and then the next thing we do is just connect up all of these miscellaneous parts. So if you want, you can make them look neater by just moving them in line. Change your track width down to something more reasonable, like 10 mils or 0.2 millimeters. Okay, this VDD does need a connection. This is only a pull-up though, so it doesn't draw much current, so you can just get away with a little track. And again, I want this on the bottom layer because it will be that way it doesn't interfere with our VDD. Well, not VDD, sorry, with our ground plane. Okay, to make this work, I actually need to put this via in the middle. Yeah, that'll be good enough. So again, there's not much current flowing through this track because it's only for pull-ups. So it'll be like milliamps of current at most. Okay, in this board, you can actually do something a bit unique, which is you can actually swap the bottom layer, and the power layer if you want, because this ground layer is just a bunch of signal, and it's not really connecting to, there are no components on the ground layer is the point. There's nothing on the back side of the board, so if you want, you can actually like swap these around. So move these to the internal layer 2, and you can make the bottom layer V-bus. Now, there are some trade-offs to doing this. Like, for example, if you scratch the breakout board on the bottom and you have like ground on the bottom, it will short. So that's a disadvantage of putting on the bottom layer. But the advantage is the bottom layer is way more thicker, like twice as thick as the internal layers in terms of the copper deposition. So you can actually put a lot more current through the bottom layer. So that's something to consider and think about. So yeah, there are pros and cons to doing that. If you're unsure, just do the standard stack up and put signal on the bottom layer, power on layer 2, ground on layer 1, and more signal on the top layer. Okay, now it's time to connect up all of the pins. So in this one, it's pretty easy, right? You just go around connecting the pins. There's nothing too difficult about this layout in particular. So connect these pins. Connect them. Maybe you can shuffle this through. Let's see. Oh yeah, you definitely can. Some people don't like vias, or they try to minimize the use of vias, but honestly, I don't really care. If you use vias in your layout, then it is what it is, right? Or not if you use vias, but if you use a via in like one instance. Some people, like, they just want to minimize the amount of vias they use for some reason, but yeah, it really doesn't matter. Unless it's like high speed signals, then it matters. High speed or RF, then you shouldn't be using too many vias. But this is all very low speed, it's just like, I don't know, a couple megahertz for the USB, or and then the other parts are like maybe a kilohertz or something for the RX and TX. Okay, next part, let's see. Oh yeah, we got that V bus still. So to connect this, I'm just gonna expand this out. And that should be plenty of current. So that's a good thing if someone connects, I don't know, some high powered, sorry, like device that uses a lot of current, then that'll be perfect. Having a huge ground plane. The chip here doesn't really use that much current, which is why I'm not too bothered about that. But you know, there are reasons to make a thick ground plane, or not ground plane, power plane for that reason. Okay, in this case, we've got a ground over here, so you gotta be careful and you gotta try not to cut that that ground connection off. So to make that work, I'm just going to move even more stuff around. Right, like that. Okay. And then you've got the RI pin. Again, if you want, you can just make it even a little bit more tinier. The track, and you can honestly, there are cases where you need to do some really tight routing and like bring stuff out to fan stuff out, and in that case you can just put the grid size way can put the grid size like down to 1 mil, although you probably shouldn't do it for everything. Okay, and then yeah, this really is a bit of a squeeze to put in. I'm just going to move V-bus to the side like that to make more room, and move this track down, move that track around, and that should be perfect. Yep. Now let's just put in the last track. I think this is the last track. Oh no, there's one more. The other sauce. Move these down. Just like that. And then yeah, let's put this sauce track in. Actually, it might make more sense to just move this resistor like that. And then now we can move sauce on the surface and we don't even need the via. It's up to you how you want that to look. Like that. And there you have it. I think that's the whole board laid out and routed out. So only last thing you need to do is, in my opinion, I don't like how these designators look on the board. So what I do is I use the selection filter tool, which is very useful. So you can press components, and then that way you only select components, not the tracks, right? And then you can click the eyeball to disable all of those ugly designators. Okay? And to top things off, okay, I think we're gonna miss the sub 1 hour, but it is what it is. To top it all off, we're just gonna resize this ground plane and resize the board so it's a lot more reasonable. Okay, yeah, we're missing the sub 1 hour, but whatever. And then make this rectangle a lot smaller. Okay. Bring those sides in. I think I might reduce the fillet size to like 50. Yeah, that looks more reasonable. Bring that USB right up to the edge. And then finally, to make the board size smaller, let's just go to board shape, define from selected objects to, while you're clicking on the keep out layer. Okay. And then finally, these polygons, let's just size them down. Oops. Size them down. You might as well add in a polygon, a ground pour to the internal layers. So I'm just going to paste that twice. Bottom layer and layer 2. Again, this just keeps everything more shielded, so better signal integrity. But if you are putting more planes, just be careful and make sure your layer order is correct. So I'm going to send a ground to back on the bottom layer, otherwise this V-bus layer doesn't get poured. And I'm just modifying the ground pour, just not the ground pour, sorry, the polygon, just to be a bit more neater, like that. And finally, I think I put these the wrong way, so I'm going to press Control L to flip it. Yeah, now they're on the right side. Control L. Oops. Ah, that's because it was with the 25mm grid, so make sure you use the right grid, otherwise the pin spacings will not line up. And that'll be a big problem for a breakout board. Cool. I think that's about it. You've now routed a chip. Congratulations. And what I like to do after this is to stick my name on it, so let's go to a schematic. Actually, no, I'll go to this little board. Something I always put on every one of my boards nowadays is just a little information panel that gives you like the commit revision and everything. And I also put this JLC text. That's just if you want to put the order number somewhere, so that they don't stamp the order number somewhere random and it looks bad, right? So bottom layer, and then just chuck this in. When you're putting your symbols, or not symbols, sorry, when you're putting text in or overlays, try to move them away from like holes and stuff, because if you get a hole, well, it obviously clips into your overlay. So I'm actually going to move this, I don't know, like that. like that. I think that's a bit more reasonable. And there you have it. That looks perfect to me. Alright, make sure you save. And then finally make your commit and save it to the server. Now, something I haven't gone over in this tutorial is how to make the design files, which I'll show you in another tutorial, along with design rules and stuff. So, oops, initial commit. So make your commit just to make sure you have all your files backed up on the Altium 365 cloud. And yeah, I think that's my thought process behind designing this simple breakout board. Hopefully it helps you guys with your own projects. And of course, if you've got questions, just let me know, whether about this board, about your real design. Okay, I think that's time. So, okay, that's not really speedrun worthy time, but it is what it is. Anyway, like and subscribe, I guess.